Hello guys, welcome to another section of Math. Let's look at this problem. Find x if x raised to the power x is equal to 10. Find x if x raised to the power x is equal to 10. X raised to the power x is equal to 10. How are you going to find the value of x? Well, let's get started to find out. First, let's write our solution. Now let's bring this problem down here. X raised to the power x equal to 10. Now, to get the value of x from this equation, we have to use what? The Lambert W function approach. Or, I don't know if you have any other approach that you can use to solve this equation here. That is okay. But here, to get the value of x from this equation, in this video, we are going to use the Lambert W function approach. Okay. But before we apply the approach, we are going to take natural log of both sides. Why? Taking natural log of both sides will help us rewrite this one in a way that will suit the approach that we are going to use. Okay, so let's take natural log of both sides. So take natural log of both sides. So let's take our natural log. Natural log of x to the power x equal to natural log of 10. Now from the one of the laws of logarithm, this x here can be written at the back here. Okay, so this one, by applying the law of exponent of logarithm, you're gonna get x times natural log of x. Okay, x times natural log of x is equal to natural log of 10. Now here we are going to rewrite this one so that we can apply our approach. Okay, so how are you going to rewrite this one? Well, the motive of rewriting it is that to apply the approach, we have to get something like a times e to the power a, or b times e to the power b. So in general, if you want to use the Lambert W function approach, you have to get something like something times e to the power something. What is multiplying the e should be the same thing as what is powering the e. Now when you have something of that nature and you use the approach, it works perfectly and it help you get your something back. Okay, so the motive of using the approach is that we want to get one of the x. We want to take away one and then leave one, so that we can get value for x in that equation. Okay, so as I say, you're going to rewrite this one. How are you going to rewrite it? Well, either we write it as x times e to the power x, or natural log of x times e to the power natural log of x. Okay, so any of them will work, but how are you going to rewrite this one? Well, because one of the laws of logarithm, when you have something like a raised to the power log of b to the base of a is equal to b, we're just going to apply that one to rewrite this one using the natural log. So you're going to write this one as natural log of x times e to the power natural log of x. Why? Because the base of this natural log is e. So when we write e and we power it with another natural log, the base of that natural log and the original base will just cancel out, giving our this x back. Okay, so let's rewrite it. Good. So natural log of x times e to the power natural log of x. Now when you compute this one, it should give you this one back, because the base of this natural log is e, and already we are having this e here. So this e and this natural log will just cancel out and you'll be left with x. And when you multiply this x by this one, to just give you what is here. Okay. So this time this will give us that is natural log of x times e to the power natural log of x. Good. Now, as I said, to apply the Lambert W function approach, you have to get something times e to the power of something. Now, when you look at what we are having here, we are having something times e to the power of something. What is powering the e is the same thing as what? What is multiplying what? The e. That is natural log of x is the same thing as what? The natural log of what? X here. Okay, which means we can apply our what? Approach here. Okay, good. Now, this one, because we cannot find any way to rewrite this one to look like this, we can't use the approach. Definitely, actually we can, but it will not give you anything back. Here, when we take the approach, it will give us one of the natural log back. You know, when you have something like something times e to the power something, and you plug into the Lambert W function approach, it will just give you what? Your something back. So when we take the w of this one, it will give us natural log of x back, and by that you'll be having what? 1x. But here, when you take w of this one, it will not give you anything back because this one doesn't suit the function, it doesn't look like this one. But if you can manage this one, if you can rewrite this one in any way to look like this, yeah, then you will definitely get what? Something back. If it is not possible, then you just leave it as it is. Okay, so here I'm just going to take Lambert W function approach of what? Both sides. Okay, so take Lambert W function of both sides. Lambert W function of both sides. So you're just going to take W of both, W of this, and also take W of this. Okay, that is the shortcut for writing the Lambert W function what? Approach. Okay, so let's take W of both sides. Good. Now, because the Lambert W function take something times e to the power something, here we are going to get our something back. So here, w of natural log of x times e to the power natural log of x will give us what? Natural log of x. But here, w of this natural log of 10 will not give us anything back, but it rather give us what? A numerical value. But if we can manage this one to, if we can manage to rewrite this one in any way to look like this, then you could have possibly get something or back. But because this one cannot be, we cannot rewrite this one in any way to look like this, we just leave it this one as it is, and we will not be expecting anything or back. Okay, so here I'm just going to get natural log of x is equal to w of natural log of 10. W of natural log of 10. Now here we're having natural log of x equal to w of natural log of 10. How are you going to find the value of x? From this equation, the value of x can easily be determined as compared to the original one. Why? Because from anytime we are having something like this, we can easily tell the answer, because from the definition of logarithm, this x here can be found. That is, the definition says that log of a number, say a, or any variable at all, is the index to which the base of the log must be raised to give the number. So to find this x here, we're just going to apply the definition of logarithm by taking e of both sides. When you take e of both sides, the base of this natural log is e, and already we are having another e as this one is looking. When you take e of both sides, it's just going to look like this one. Okay, this and this. Okay, so the base, the e and this natural log will just cancel out, and to be left with what? X. And when you take e of this, we're just going to get e raised to the power w of natural log of 10. Okay, so here x is equal to e raised to the power w of natural log of 10. So the value of x from the equation is what? E raised to the power w of natural log of 10. Now somebody may ask, why is it that we didn't get any numerical value here? We can get a numerical value provided we have what? A product log or a product log calculator. Another name for the Lambert W function is what? Omega function or product log. So if you have product log calculator, you can punch this on that calculus and it will give you what your numerical value and it will give you what your numerical value. But here, if you want to find the approach by doing inspection, this W here represents what? Any integer at all. Any integer at maybe 1, -1, -2, 5, 8, blah blah blah. When you point this one on scientific calculus, just replace this one with any variable, any integer at all, and it will give you what your numerical value. But I will advise you not to do that, because only the product log calculator will know the actual value of this W here. So if you reach here and you want to get your numerical value and you just go by what I just said, by maybe replacing this one with maybe any figure, and then you just write whatever you get there as your answer, you get it wrong. With the product log calculator, when you punch this one here, to just give you what the numerical value. But with the scientific calculus, when you point this, it won't be able to determine what's supposed to be replaced for W. So since product log calculator is not all that common and it's not all that easy to determine the numerical value for this one, when we reach here or when we get something like this, we just leave it as answer to what the question. Okay, so the value of s from the equation is what? E raised to the power natural log of what? 10. Okay, so therefore s is equal to e raised to the power w of natural log of what? 10. Okay, now when you plug this one into the equation, you could see that both left and right hand side will be what? The same. Okay, all right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching. I'll see you in another video. Bye for now.